This is your today's question, which is based on the reactions of the alkenes, and you have been given this cyclic allyl bromide kind of the compound, and this compound is undergoing the bromination in presence of the carbon tetrachloride as the solvent. In that case, it is given that two products are formed. You have to decide the structure of these two compounds and which one is the optically active and which one is not the optically active. You have to decide this thing. Okay, so here I am doing the bromination. This is the usual course of the reaction. The double bond which is present here, this will attack on this particular bromine and grab this bromine as the brominium ion, while this bond will go to this Br and your Br negative will be removed from here. So what will happen? This cyclic intermediate will form in that case, right? This is the brominium ion, cyclic brominium ion we will form in that particular case. The Br negative which I have eliminated in the first step now have the two possibility to react this particular cyclic brominium ion. First, you can see here, this is the top attack. But why? Because this the adjacent Br is on the bottom side. It is alpha. Alpha means going below the plane. So definitely this Br negative must attack from the top, right? When it will attack from the top, so bond will form above side, that means the with beta configuration. So this is the top attack, and the Br which is attaching here, so Br will attack here. This electron pair will go to the Br, so two Br will be attached here. So this Br, you can see it is at the beta position, beta which is represented by the solid wedge in case of the stereochemistry, which shows the above projection in the system, right? So this is above the plane, this already given in the below plane, right? Below the plane. But the second option is then the bottom attack may also occur. So this will attack on through the bottom side. So when it will attack through the bottom side, so this will have the alpha position, this Br in this particular product. So this is in the bottom one, and definitely when this is the bottom one, then this particular bromine will project above, right? So this is above, right? This is above the plane. So these two product we are having, while this particular product is optically inactive due to the presence of the plane of symmetry, right? You can insert an imaginary plane from here to here, right? So when you insert the imaginary plane, then you can see this particular half and this particular half identical. So this is actually your meso compound and it is optically inactive, while this kind of plane of symmetry is not present in this particular compound, because you cannot bisect this molecule in the two identical halves, because this is below the plane, this is also below the plane, but this is above the plane. So this is optically active in that case, right? So I hope you understood the thing, right? If you understood the things, please like the lecture and subscribe the tetrahedron chemistry classes.